last thing we're going to do is some examples from 1.4. I took a few of these diagrams from your textbook, so that's why they look like actual pictures. So for number 1, use figure 4 to answer the following questions. Name the vertex and the sides of angle 4. So if you take a look at your picture, angle 4 is up here. Its vertex is going to be C. That is where it comes to a point. And then the sides, remember the sides of angles are rays. Always start with your vertex when you name them. So that's going to be ray CB and ray CD. Name all angles adjacent to angle 6. Here's angle 6. Remember, angles that are adjacent are going to have a common vertex, and they're not going to share any interior points. So in this situation, that would be angle 7 as well as angle 5. And you could name those with letters if you prefer. Part C says name the 3 angles that have B as a vertex. B is right here. Again, you could name 2 of the angles with numbers if you want, but like the angles 3 and 2, but to keep it consistent, let's practice naming our angles with 3 letters. So you could either call the first one angle 3 or angle CBD. You could say angle 2, or you could say angle ABD or DBA. And then you could also name the straight angle. That's angle CBA. And then is D an appropriate name for an angle in this figure? That's going to have to be no. And if you take a look, angle D is down here. And the reason that's not an appropriate name, D is the vertex of multiple angles. If you say angle D, I don't know if you're talking about 5, 6, 7, the straight angle, any combination of those angles. So no, because D is the vertex of multiple angles. Number 2, given figure 5, state whether you can reach the conclusion shown. So in figure 5, we have several intersecting lines, and angle FOB is 50 degrees. And you can tell that it's 50 degrees because the picture is labeled as such. So the first thing, it says the measure of angle AOC is 90 degrees. Here's angle AOC, and when you look at it, you might think, yeah, that looks like a 90-degree angle. I'm going to say yes. However, we can't assume. There is no right angle box there, and the directions didn't state that the lines were perpendicular, and it didn't state that it's 90 degrees. We can't assume. It might just look like it's 90 degrees, but maybe be 91 degrees instead. We just can't be sure. So this one we are going to say no. Angle DOC is 180 degrees. Well, angle DOC is right here, and that's a straight angle. And straight angles are always 180 degrees. Anytime you see something that looks like a straight line, it's okay to assume it's a straight line. Other things like right angles and things like that, you can't assume, but you can assume straight lines. So we're going to say yes. can we reach the conclusion that the measure of segment AO, that's right here, is congruent, or I'm sorry, is equal to the measure of segment OB? Again, it looks like it. However, we are not told that O is the midpoint. We're not told that line CD is a bisector, and there's no dashes to indicate that they're congruent. So we just don't have enough information to state that. So we're going to say no. We would need some additional information there to know if that was a fact or not. Angle AOC is congruent to angle BOC. That's these two angles here. Again, they look awfully congruent. They might be, however, they're not marked as congruent. We don't know that those lines are perpendicular. If they were perpendicular, they'd be right angles, and then they would be congruent, but we just don't know that for sure. We need additional information for that. That's going to be no. And then last one for this. Can we conclude that the measure of angle AOF, that is this angle right here, is 130 degrees? The answer to that one is yes, because down here, angle AOB is a straight angle. Straight angles are always 180 degrees. And if angle FOB has a measure of 50 degrees, then angle AOF has to have a measure of 130 degrees. Number 3, in figure 6, ray BD bisects angle ABE. Solve for x. So ray BD bisects angle ABE. Remember, our angle bisector gives us two congruent angles, so we can say that angle 1 is congruent to angle 2, and I'm going to mark that with the arcs. First thing we're told is that the measure of angle 2 equals 2x, and the measure of angle DBC equals 4x plus 54. Something that might help you know, you're going to have to do multiple examples using the same diagram. So keep in mind, each example is separate. You might be given different information about the same angle. So information given with A only goes with A. Information given in B only goes with B. So for part A, it's telling us that the measure of 2 is 2x. And the measure of angle DBC, that's this entire part here, is 4x plus 54. So what we're going to do here is use our segment addition postulate. We know that angle ABC is a straight angle, which means the sum of these two angles is going to have to be 180 degrees. So we're going to do 2x plus 4x plus 54 equals 180. Combine your like terms, 6x plus 54 equals 180. Subtract, and 6x will equal 126. Then divide, and you should get that x equals 21. And it just said to solve for x, so we don't need to plug that back into anything. So on to part B. Again, make sure we understand that angles 1 and 2 are congruent. And then in part B, you're told that angle 1 has a measure of 7x minus 2. And that angle 2 has a measure of 6x plus 5. Well, you were told that you have a bisector, and your bisector is going to give you congruent angles. So what we're going to do here is set those two angle measurements equal to each other. Again, congruent angles are going to have equal measures, so set the measures equal. 7x minus 2 equals 6x plus 5. So subtract your 6x over, x equals, add your 2 over, and you should get 7. And then last one, for part C here, you're told that the measure of angle 1 is x minus 2, And the measure of angle EBC, that's this part here, is 3x plus 14, and we need to solve for x. Now, we don't know if angle 1 and EBC are congruent. It didn't say that. But there are some other things we know. First of all, we know angle ABD is a straight angle. It's going to have a sum of 180 degrees. We also know that angle 1 and 2 are congruent due to our bisector. Therefore, a strategy for this, if angle 1 is a measure of x minus 2, angle 2 will have that same measure. And then you can add all three angles up using the angle addition postulate and set them equal to 180 degrees. Or if you prefer, instead of having to add x minus 2 twice, you can also do 2 times angle 1, which is x minus 2, because again, you know that both angles are going to be the same, plus your other angle, 3x plus 14, equals 180. Distribute the 2, 2x minus 4, plus 3x plus 14 equals 180. Combine your like terms, 5x plus 10 equals 180. Subtract your 10, 5x equals 70, and divide that out to get 34. Okay. Let me know if you guys have any questions. Don't forget to get the content check done before next class. So for Maroon Day students, that's Tuesday. Gold Day students, that is Wednesday. Have a great day.